So this week you have quiz 7 due, which is over 5.5 through 6.2. Again, I'll get quiz 6 graded, and I'll try to get quiz 7 graded quickly this week too, because next week we have test 4 due, and it's over that material. So we'll get stuff done, I promise. Today we are talking about 6.3 and 6.4, which has to do with unit conversion. And so then after that, it's 6.5, which is finishing up unit conversion. Like, we are just speeding through material. It's crazy. So before I get started, are there any questions about homework, class stuff, whatever? Do you have a question? I might have an answer. Okay.
There's a quiz this Tuesday. I was in the kitchen real fast, so I don't know if I missed it.
I'm sorry, what did you say?
I ran out to the kitchen real fast. Did you say if there was a quiz on Tuesday or not?
Yes, this Tuesday we have a quiz 7, and then next week on Tuesday we have a test. So yeah, so this week we're focusing on the quiz, and then next week you'll focus on your test.
Okay.
So I will try to get last week's quiz and this week's quiz. Oh my gosh, that's a tongue twister. Graded as soon as I can, so that you can have both of those to review for the test that's next week. Okay. All right. Let me import our note pages for today. Okay, so the unit that we are going to convert first, I'm going to start with American units or standard units. The American system or standard system is two ways that you will hear it referred to. And again, I'm starting here because that's what we're comfortable with, right? And then 6.4, we're going to talk about metric units. And then on Wednesday, we're going to focus on switching between the two systems. So when you're working on your homework, you're going to want to have this notebook page with you because it has all of our units on it. So we have units of length. And so we've got these equivalency. 1 foot is 12 inches. So a unit rate for this would be that 12 inches is to 1 foot, or 1 foot is to 12 inches. So we have a relationship between mile and feet, yards and feet, and then we could easily go from miles to yards using the relationship that we already know with feet. And then we've got units of weight, so pounds and ounces, or tons and pounds, volume, so liquid volume, and then units of time. And then we've got these, so this ratio that I wrote up here are also referred to as conversion factors. So those are going to be really helpful for us, and we're going to use those on our next page. So it says change 2.5 miles to feet. So we're going to say that 1 mile is equal to how many feet? Well, if we go to the previous page, we can see that 1 mile is equal to 5,280 feet. And how am I going to convert this? Well, we use something called dimensional analysis. And what does that mean? Well, I'm going to take the unit I'm trying to convert. I'm going to write that over 1. So I have 2.5 miles over 1. And I want to multiply it by my conversion factor. My conversion factor is 5,280 feet is to 1 mile, or I can write it as 1 mile is to 5,280 feet. So I have to choose which one do I want to use. Well, when we're trying to convert our units, we want our unit of measure that we are canceling to be diagonal. So if I have miles in the numerator, I need to have miles in the denominator. So looking at the two fractions that I have written, this is going to be the conversion factor I want to use because it has 1 mile in the denominator with 5,280 feet in the numerator. So then once we have that written out, we're going to multiply straight across the top and straight across the bottom. Again, we're not using this diagonal line to mean cross multiplication. We're just saying we want to make sure our units of measure are diagonal from each other. So multiplying through, I'm going to have 2.5 times 5,280. So 2.5 times 5,280 gives us 13,200. And then because miles cancel with miles, we're left with feet. So again, when we're doing this, we want to make sure we write out our conversion factor, then represent that factor as a fraction, and then set up the multiplication of two fractions so that we can cancel our unit of measure. So for number 2, we've got 5 3/8 pounds. So first of all, 1 pound, we look on our previous page, 1 pound is 16 ounces. And we know that it wants us to convert pounds to ounces. So 1 pound equals 16 ounces. So we're going to take 5 3/8 pounds and convert it to ounces. Now, before I can convert it to ounces, I need to first switch it from a mixed number into an improper fraction. So we're going to take 5 3/8, and we're going to do 5 times 8, which is 40, plus 3, giving us 43. And we get 40, whoops, why am I writing this 8? 43/8 pounds. And then we want to multiply it by our conversion factor. So again, I want pounds to cancel. So I'm going to write my conversion factor as 16 ounces over 1 pound. And then we're going to multiply straight across the top and straight across the bottom. And I want you to finish that calculation and tell me what you get in ounces. Okay, so we have two choices. We can multiply straight across the top and then reduce, or we can reduce before multiplying. So I am a big fan of reducing before multiplying because I don't like to deal with big numbers when I'm multiplying. So I can cancel 8 into itself once and 8 into 16 twice. Now multiplying across, my pounds will cancel with pounds, and I just have 43 times 2, which is 86 ounces as my final answer. Okay. So number 3 says change 10,000 ounces to tons and express your answer as a fraction in lowest terms. So in order to convert 10,000 ounces to tons, we need to first convert from ounces to pounds, and then from pounds to tons. So going from ounces to pounds, we know that 16 ounces equals 1 pound, and that 2,000 pounds equals 1 ton. So I want you to go ahead and do that conversion and then send me your answer in a direct message. Is a either a decimal to 4 decimal places or as a fraction in reduced terms. Okay, so this is what we call a chain conversion. And so I want to go from ounces to tons, which means we need to go ounces to pounds to tons. And so I've got my 10,000 ounces. And I need to multiply it by my first conversion factor, which is 16 pounds equals 16 ounces, equals 1 pound. So because I'm trying to get rid of ounces, I'm going to put the 16 ounces in the denominator. Therefore, if I put the 16 in the denominator, I need to put 1 pound in my numerator. Then my second conversion is going to be going from pounds to tons. So because I have pounds now, and again, we can just think about canceling these ounces out. Since my unit of measure that I have now is pounds, I'm going to put 2,000 pounds in the denominator, right? We're using this conversion factor, and 1 ton in the numerator. So if we multiply straight across, hold on, it's not updating. Hold on 1 second. I don't know what it's doing. Oh, it's being really weird. I apologize. Hold on, everyone. My screen, like my iPad stopped feeding to my shared screen. Okay. Okay, so now you can see everything that I've been writing that wasn't showing up. So we're going to multiply straight across the top and straight across the bottom, which is going to give us 10,000 over 16 times 2,000. And because our units of measure have canceled throughout, right? These pounds cancel with those pounds. I just have tons left. So if I take 10,000 and divide it by 16 times 2,000, so 16 times 2,000 gives me 10,000 over 32,000, which reduces to 0.3125 tons. Now, if you were doing your homework and they wanted your answer as a fraction, okay, let's think about how we could represent this as a fraction. Well, if I have 10,000 over 32,000, we can cancel 3 of the zeros with 3 of the zeros, because what we're doing there is dividing by a factor of 1,000, giving me 10 over 32. Dividing the numerator by 2, the denominator by 2, I get down to 5/16 tons. So that's how we could represent it as a fraction or as a decimal. So either of these answers are okay. It just depends on how they want it. So 3 was confusing. So let me hear from you what tripped you up there. If anything tripped you up. I don't want to assume.
I think just setting it up.
Just setting it up, yeah. So always write out what your conversion factors are first, right? And then I want you to think about getting those units diagonal from each other, okay? And that will help you determine which way you put the fraction in. So number 4, we're changing seconds to days. So if we think about our units of measure with time, you can see that we've got seconds to minutes, or seconds to minutes, minutes to hours, and hours to days. So there's 3 conversion factors, 3 steps that we are making there. So I want to go from seconds to days, which means I'm going to go seconds to minutes, minutes to hours, and hours to days. So Let me put this on a new sheet only because it's a really big problem. So hold on one second. Let me get a blank page. So we're going to convert 4,493,469 seconds to days. And like I said, we're going to go seconds to minutes, minutes to hours, and hours to days. So thinking about the unit conversion that we're going to set up. Ashley, we're on page 101 at the bottom right-hand problem, okay?
Thank you.
So conversion factors between seconds and minutes. So 60 seconds equals 1 minute. So now the question is, do we write that as 60 seconds over 1 minute or 1 minute over 60 seconds, right? Because they're the same conversion factor. It's just how do you write it, up or down? So if I'm starting with my unit of measure that I'm trying to convert, so we always do that first, and we write it over 1. So because I have seconds in the numerator, that means when I multiply, I need to get seconds in the denominator. So which of those two fractions has seconds in the denominator? The second one. We're going to use this one because it's going to give us the seconds in the denominator, which allows us to cancel with the seconds in the numerator. So I've got 1 minute that I'm going to put in the numerator and 60 seconds that I'm going to put in the denominator. My second one, and now I want to go from minutes to hours. So we know that 60 minutes equals 1 hour. So again, we can do 60 minutes over 1 hour or 1 hour over 60 minutes. Again, which factor am I going to choose? Well, I'm going to choose the factor that has the minutes in the denominator because I'm trying to cancel these minutes with those minutes. So which one has minutes in the denominator? The second one does. So I'm going to do 1 hour in my numerator and 60 minutes in my denominator. Last, I'm going to do hours to days. And we know that 24 hours equals 1 day. And again, are we going to do 24 hours over 1 day or 1 day over 24 hours? So I'm trying to cancel hours. We're going to put 24 hours in the denominator because again, we want hours to be diagonal from it, right? We've got hours and hours. And then 1 day will be our numerator. So going through, it's helpful to just make sure, can we cancel all of our units of measure? So I see seconds here, cancel with those seconds. Minutes, cancel with these minutes. And hours, cancel with those hours. So as you can see, moving through, our units of measure have canceled. So we end up with days, but we still have the numbers left, right? We've got 60, 60, and 24 in the denominator. So if we multiply through, right, we go straight across the top, straight across the bottom, I have 4,493,469 over 60 times 60 times 24. And this is days. So again, 4,493,469 over, and then oops, we get 86,400. And then the last is actually dividing those. And this gives us 52.0077 days. And we're just going to round that to 52.0 days. And I'm including the 0.0 portion on there to indicate to us that we had to round that value and it's not an exact number of 52 days. So this is one where we had to make 3 steps as we moved through the process. And so at each of those steps, we had to come up with our conversion factor and multiply. So before I move forward, what questions do we have about these? Okay, so like I said, the first part, 6.3, has to do with converting within the American system. And 6.4, we focus on converting in the metric system. And the nice thing about the metric system is that it's all based upon powers of 10. So with metric system, you have these prefixes, and prefixes mean the value that comes before the unit of measure. And what does that mean? Well, we know that we've got something like kilogram. So kilo, this is prefix, means 1,000. So writing kilogram literally means 1,000 gram. And that's the nice thing about the metric. It tells you what you're dealing with. So other ones that we're used to is centi, meaning 1/100th, and milli, 1/1000th. So centimeter is 1/100th of a meter, and millimeter is 1/1000th of a meter. So if we think about how do these compare in terms of place values. So if we have our decimal point in our unit here, deca, hecto, and kilo are all larger values, where deci, milli, and centi are all smaller values. So in case you don't remember what all the prefixes mean, we've got some equivalencies written out here too. So 1 kilometer is equal to 1,000 meters, and the abbreviation is km. 1 hectometer is 100 meters, hm. 1 decameter is 10 meters, or dam. A meter is just m. A decimeter is 1/10 of a meter, or dm. You'll also see this as 0.1 meters. Centimeter is 1/100th, and cm, and millimeter is 1/1000th of a meter, or mm. So these are for our units of length. So for units of length, everything is built off of meter being the standard. For units of mass, we have grams. And then units of volume are liters. So again, we have these relationships already set up here. And to make these ones easier, we can also say that 1 gram is equal to 10 decigrams. 1 gram is equal to 100 centigrams, and 1 gram is equal to 1,000 milligrams. We go back to the previous page just so we fill in that same information. For these ones, to make it easier, 1 meter is equal to 10 decimeters. 1 meter is equal to 100 centimeters, and 1 meter is equal to 1,000 millimeters. And I find those to be easier to deal with than using the fractional portion, okay? And then, like I said, we've got units of volume with liters. Kiloliter is 1,000 liters. Hectoliter is 10, or is 100 liters. Decaliter is 10. And then we've got our fractions. So 1 liter is equal to 10 deciliters. 1 liter is equal to 100 centiliters. And 1 liter is equal to 1,000 milliliters. So we've talked previously about multiplying and dividing by powers of 10. So multiplying a decimal by 10 to the n will move the decimal point n places to the right. So what they're showing you is if we have 3.2567 times 10 to the second, it's like multiplying by 100 because 10 to the second is equal to 100. And multiplying by 100 moves this decimal place 2 points to the right, giving us 325.67. Versus dividing is going to move our decimal point to the left. So thinking about the relationships that we have, we want to change 6,290 centimeters to meters. Now remember, for our units of measure, we know that 1 meter is equal to 100 centimeters. And again, what if you forget that? Where can you find it? Again, if you go back to your table, your units of length are right here, and you can use those. Again, we wrote out these shortened versions too to kind of help you with those. So we've got 1 meter equals 100 centimeters. So go ahead and convert 6,290 centimeters to meters and send me your answer in a direct message. Okay, so if we set up our conversion, we're going to take 6,290 centimeters and place it over 1. We're going to multiply by the conversion factor, again deciding, does the centimeters go on top or did the centimeters go on the bottom? Because we want to cancel centimeters, we need to have centimeters in the denominator, which means the 100 goes with it, and we have 1 meter in the numerator. Multiplying through, we're dividing by 100, so we're going to move our decimal 2 times, giving us 62.9 centimeters. Okay, so I want you to try number 2, convert 5.3 kilometers to meters. So we're trying to go from kilometers to meters, right? So kilo, remember, means 1,000. So 1 kilometer equals 1,000 meters. Again, I don't expect you to memorize this right now. If you need to check it, you go back to our units of length. And right here, it says 1 kilometer equals 1,000 meters, right? So we've got 5.3 kilometers. And we want to convert them from kilometers to meters. So that means we need to put the 1 kilometer in the denominator and the 1,000 meters in the numerator. This is going to cause our kilometers to cancel. And what we're really doing is taking 5.3 and multiplying it by 1,000. We multiply by 1,000, we get 5,300 meters as our answer. So again, it's always identifying your conversion factor first, and then you have to figure out, is it up or down? How do you place that factor? Okay. So number 3, we're going from grams to kilograms. So if we go back to this page, we need to write down, what is our conversion factor between grams and kilograms, right? What do we have? So we can see that 1 kilogram equals 1,000 grams. So we need to take 26,458 grams. We put it over 1. We multiply it by the fraction. Again, you need to decide, how is that going to be? And then we get an answer out in grams. So go ahead and tell me what you get. Okay, so we want to put the 1 kilogram in the numerator and the 1,000 grams in the denominator. So dividing by 1,000 moves our decimal place 3 times to the left. giving us 26.458 grams. Okay, so number 4 wants us to go from centigrams to milligrams. So how can we go from centigrams to milligrams? Right now, we've been going from like our unit to measure meters or grams to a multiple of that, but now we're going between these. So if we look at centigrams and milligrams, in order to go from centigrams to milligrams, we divide by 10. And in order to go, and so 1 centigram is equal to 10 milligrams. Okay. So using this unit of measure, we're going to go back to our problem. We're going to say 1 centigram is equal to 10 milligrams. So go ahead and send me your answer to number 4. Also, I misspoke on this page. I apologize. When we're going from centigrams to milligrams, we're going to multiply by 10. And when we go from milligrams up to centigrams, we are dividing by 10. Okay, and so the reason for that, the reason we multiply is that milligrams are smaller than centigrams. So there's more milligrams to a centigram than trying to go the opposite way. I find that really confusing, which is why I really like using the unit ratios like this and setting them up as the fraction and deciding which one goes on top and which one goes on bottom. So with our problem, we've got 26 centigrams and we want to convert it to milligrams. So we've got this equivalency, which again, we can write as 1 centigram over 10 milligrams, or we can write it as 10 milligrams over 1 centigram. And we have to decide which of these fractions to use, right? So because I'm trying to cancel centigrams, that means centigrams needs to be on the bottom, which means I want to use that conversion factor. So knowing that I have to use that one, I'm going to put my 10 milligrams on top, my 1 centigram on the bottom, and I'm going to multiply straight across the top and straight across the bottom. These centigrams cancel, and I get 26 times 10, giving me 260 milligrams as my answer. Okay, number 5 says change 26,458 milliliters to liters. So I want you to do this one on your own. Look on the previous page at your unit of measure abbreviation for units of volume and relate milliliters to liters. Okay, so we know milliliters. So a milliliter is 1/1000th of a liter. So how do we use that information? Milli means 1/1000th. What that means is that 1000 milliliters equals 1 liter. So putting 26,458 milliliters on top, we're going to use 1000 milliliters on the bottom and 1 liter on top. Dividing causes our decimal to move 3 times, giving us 26.458 liters. Our last one is changing kiloliters to centiliters. What I want you to do here is go from kiloliters to liters, and then from liters to centiliters. The centiliters are little, so we're going from the top end down to the very bottom. So think about what your relationships are there. Okay. Okay, so how can we work on this when we're confused, right? So let's look at our previous page. It's helpful. So these, we already have these nice relationships already set up, right? It's these ones that we had to convert, right? We had to think about them a different way. So we know that 1 kiloliter is equal to 1,000 liters. And we know that 1 liter is equal to 100 centiliters. So we're going to use those 2 conversion factors, right? This one's right here, and this one goes with that one. So going back to our page. So if you don't, sorry, hold on 1 second. If you don't have these extra conversions written on your page in your notebook, I would write them down to help you instead of trying to rely on these fractional parts. I don't like those. I think they're confusing. Okay. So if we go back to our problem, we've got 4.8 kiloliters. So kiloliters to liters, we know that 1 kiloliter is equal to 1,000 liters. And we know that 1 liter is equal to 100 centiliters. I don't know why I wrote an H, it's supposed to be an L. So 4.8 kiloliters and we're going to multiply it by our 1,000 liters over 1 kiloliter. Again, why are we doing it this way? We're doing it this way because we need kiloliters to be diagonal, right? If this one's up here, that unit of measure, that same unit of measure needs to be below it. And then we're going to multiply by 100 centiliters over 1 liter. Again, why? Because we have a liter up here, so we need a liter down there so that these cancel with each other. We're multiplying straight across. So when we multiply by 100 and then by 100 again, we end up with 48,000 centiliters. Oh, shoot, I'm missing a zero. How did I know I was already missing a zero? Well, when you're multiplying by powers of 10, you're just going to add your zeros up. So I've got 3 zeros here and 2 zeros here, which means my answer needs to have 5 zeros in it, giving me, oh, not 5, excuse me. It only has 4 because we need to use one of them to get around. There we go. So we have 480,000 centiliters as our answer. Okay. When you're doing your homework, make sure that you have your notebook with you. I think your textbook has these conversion factors in them as well, but obviously we've added some of our own notes to your notebook. And so you just have to practice them. That's all I can tell you in terms of how do you get better at them, okay? So on Wednesday, we're going to look at converting between American and metric and going back and forth. So I encourage you to try the homework for 6.3 and 6.4 before then, so that we can go over any questions you have about problems that you're not getting right on your homework because you're having difficulty with the conversion, okay? And then we can go over those questions because it's really helpful to get that stuff ironed out before we start moving between the two systems, okay? So any last questions for me? All right, well, I hope you all have a good day. Don't forget your quiz is due tomorrow. I will get everything graded. I apologize. I will see you on Wednesday, okay?
Thank you.
You're welcome. Have a good day.